Hello, this is the Exam 3 review, Part 1 for Math 310. I suggest that you pause the video at the beginning of each problem so that you can work it on your own and then play the video for that problem to compare your work. Let's get started. In this problem, you are to simplify, and you need to realize that 7 minus w and w minus 7 are opposites. That means when you cancel the opposites, you end up with -1. So in this case, your 7 minus w and your w minus 7 cancel to leave -1. So that's your answer. Notice that this only works when two things are subtracted. If they're added, this does not work. So a plus b, the opposite of a plus b is -a minus b, and that doesn't help you. So a minus b and b minus a are opposites. In this problem, you are to simplify the expression or reduce it, and so your first task is to factor out common factors. In the numerator, 7 goes in to 7 and 14, and when you factor it out, you're left with 7 times m minus 2. And for a brief reminder, you can write 7 and then take what you already start with and divide each term by 7, and that will give you m minus 2. But don't forget that you need to include your 7 out here. Okay, so in the bottom we have a difference of squares. So we have m squared minus 2 squared, and so that's going to simply be m plus 2, m minus 2. So for a difference of squares, you add them and subtract them, meaning you add the bases and then you subtract the bases. So you don't add m squared and 4, you add m and 2. Okay, now we are down to our as much as we can factor, so we can go on to our reducing. M minus 2 cancels with m minus 2. That's all that cancels, so we're left with 7 over m plus 2 as our solution. Okay, in this problem we are to factor also. So when we factor, we go through the steps. First we say, is there a greatest common factor in the trinomial? So let's look at the numerator. There is no greatest common factor. The next question we're going to ask, is it a special case? Now it isn't a difference of squares because that involves a binomial, only 2 terms. Same with sum and difference of cubes, it isn't either of those. So the last thing you have to ask is it a perfect square trinomial? And that means your first term is a perfect square and your third term is a perfect square. In this case, 15 is not a perfect square, so we can ignore our special cases. The next question we ask is there a 1 in front of the lead term? So here, there's a 1. That means we can use reverse FOIL, and reverse FOIL is easier than grouping, or at least it takes fewer steps. So for our numerator, we're going to come over and write, we have to find 2 numbers that multiply to -15 and add to 2. And so 15 has 5 and 3, and it has 15 and 1. Well, 5 and 3, the difference of 5 and 3 is 2, and we have to multiply to get a negative number, so one of those numbers is going to be positive, one is going to be negative. If the larger number is positive, then when we add them, we will get a positive, which is what we want. So our 2 numbers are 5 and -3. So we can simply rewrite the numerator. I'm going to just put numerator out here as f plus 5 and f f minus 3. Okay, now let's do our denominator. We come over, same thing, we don't have, it checks out all the way. We don't have a greatest common factor, we don't have a special case, we don't have a coefficient in front of the lead term f squared that is different from 1, so we can use reverse FOIL, and that means we need two numbers that multiply to give us 21 and negative 21 and add to give us 4. Well, 21 is 7 times 3, and the difference of 7 and 3 are 4, so you have to figure out which one is positive and which one is negative. Your end result has to add to give us a positive number, so you want your largest number again to be positive, so those are our two numbers. So we can simply go to the denominator and write f plus 7 and f minus 3. We factored our numerators and denominators. Now we can cancel, and the f minus 3's cancel, so we're left with f plus 5 over f plus 7. In this problem, we're going to multiply. So we have to go through the same steps, but we have two different fractions that are multiplied together. So let's start by factoring out. Looking at the first term, this is the first term. The denominator, it does have a greatest common factor, so let's rewrite it as 5 times m minus 3. The denominator has 7 times m plus 3. Now notice m minus 3 and m plus 3 are not opposites. The opposite of m minus 3 is 3 minus m. So you cannot cancel out m minus 3 and m plus 3. In the second denominator, we have the common factor of 3, and numerator, and in the denominator, our common factor is 11. So now let's see what we can cancel. The m minus 3's are identical, so they cancel. The m plus 3's are identical, so they cancel. And then we look at our numerators. We have 5 times 3, and in our denominators we have 7 times 11. None of that cancels, so we're left with 5 times 3 is 15 over 77. In this problem we have a division. That means our second fraction needs to be flipped so that we can change it to multiplication. Let's go ahead and do that. We're going to rewrite our first one exactly the same. We're going to flip our second, and we're going to change division to multiplication. Now we need to see what we can factor. The first numerator is a difference of squares. It's b squared minus 4 squared. So we can add and subtract the bases. B plus 4 times b minus 4. The denominator is already simplified. And on the second term, both the numerator and the denominator are simplified. Okay, notice you cannot cancel this b and this b, because that would give you b over 4 minus 1, and that's not what this here is. So if it's added or subtracted, you can't cancel it. You can only cancel terms that are factors, that are multiplied together. And in this case, the whole of 4 minus b is a term, and it has to match 4 minus b on top, or else you can't cancel it. The next thing is to notice none of these are identical. However, we do have opposites, b minus 4 and 4 minus b. So if we cancel those opposites, we're left with negative 1. So now we rewrite what we have left because nothing else cancels, And to represent that -1, we just put a negative sign in front. So on top, I'm going to put the b first because it'll be easier for my next step. That's what we have left, and our denominator is completely done. Now, you will be allowed to enter it this way because that's the way it's set up, but truly to simplify it, you need to go ahead and distribute that -b on top, and then you have completed the problem. So this or this is acceptable as your final answer. This problem says to find all numbers not in the domain and then give the domain in set notation. If you had looked at this problem and not read the directions, you might have gone ahead and factored the denominator and canceled any like terms or any identical terms, and you would have gotten the problem wrong. So what you need to do differently is to see if you can find any value of x that is not allowed for a solution, and that would mean if there is any value of x that would force the denominator to be 0, then you would end up with dividing by 0, which is undefined. And remember what you learned in class. This is what happens when somebody divides by 0. And that's why it's so important for us to learn how to find numbers that are not in the domain. So to do that, we look at the denominator. We don't have to worry about the numerator. The numerator could be something like 7x cubed plus 14x minus 58. Or it could be something with a lot of variables. It doesn't matter, though. It does not matter what the numerator is. All we're concerned about for this kind of problem is the denominator. What values of x make the denominator 0? So our task is to factor the denominator, and in this case, since there's a 2 in front of the x squared term, we do that by grouping. So we need to find two numbers whose product is -12 and sum is +1. When we find 4 and -3, then we rewrite the expression 2x squared, and we also are going to have the -6 at the end. But instead of x, we're going to write -3x plus 4x. Now you notice that over here I had the 4 first and the -3 second. But here I put the -3 first and the 4 second, and I did that on purpose. It makes it easier when this is a plus sign to do the grouping. If this is a subtraction, then you have to be very careful with your negatives. So now we're going to group the first two and the last two terms. And in the first group, we have the common factor x, leaving 2x minus 3. In the last group, our common factor is 2, also leaving 2x minus 3. So now we can pull out the 2x minus 3 from both of those terms, and that leaves x plus 2. So that's our factorization of the numerator, and we're going to set it equal to 0 to find out what values of x will make it 0. So in the first case, we have 2x minus 3 equals 0, and in the second case x plus 2 equals 0. Because if either of those equals 0, then the whole thing will equal 0. So we add 3 to both sides and then divide by 2, and we find out that when x equals 3/2, that will make the denominator 0. Over here we just subtract 2 from both sides and find out that when x equals 2, that will make the denominator 0. So what is the domain? Remember that domain is all the possible values of x. So for x, we can use every value of x except for 3/2, and -2. So you have to know how to write this in set notation, which looks like this. So you can close out this video and go on to the part 2 of the Exam 3 review videos.